Hi, my name is Sean Olson. This is a video demonstrating some of the basic principles of using 3ds Max as your level editor for the source game engine. In this video, we're going to explore a few basic concepts to help you learn how to distinguish what is valid for world geometry and what is not valid for world geometry and needs to be a model. As always, when setting up your scene for level design, there are a couple things you should start with. And the first is to set the grid spacing and grid size. We're going to right-click the Snaps toggle and choose the Home Grid option. We want our grid spacing to be a number that's better for level design. I'm going to choose 64 in this case. When I do that, you'll see that the home grid got a little bit bigger. If I want this to go out more, I can just choose that spinner to go up. Also, for level design, especially at the initial stage, you should always turn off all snaps except for snap to grid. You may at other times turn on other snaps, but for the starting point, always use snap to grid. Your repository for basic primitives are under the Create tab in the Command panel over on the right. Once you go to the Create tab, you'll want to go to the Geometry area, and here you'll find your primitives. And we're going to start with box, and we're going to just create boxes for now. Turn on snaps, and if I make this box here, these are in essence the kind of things you might do to make a level. Floor, wall, etc. Now these objects are perfectly valid for your level, just like boxes and hammer. However, there are considerations you must keep in mind. First, I'm going to hit F4. When I hit F4, it turns on Edge Face Display. So all of the edges are displayed here. You may not always see them in the viewport here, but they're there. You can see this as an example, the highlight. The edges are highlight. If we go to the Modify panel here, notice that the length segments, width segments, and height segments are all set to 1. This is a valid geometry just as a box primitive with these settings. However, if I change any of these settings above 1, this is no longer valid world geometry. This is an important concept to keep in mind. You cannot have individual nodes in your scene that are broken up with this way. Each side, each polygon, each section must be composed of a single plane. You can't have multiple coplanar faces. In this case, each side of here has 4. If I change this down to 1, this still has 2. We have 2 coplanar polygons. We cannot do that. So always keep these down at 1 when you're making boxes. There are other primitives that you can use that this same principle applies to. For example, the cylinder. If we make this cylinder, it is invalid because of all of these coplanar polygons. Each column is composed of 5 rows of coplanar polygons up and down here. We need to change that. Over here in the height segments, if I put that down to 1, now this is valid world geometry. Anything above, that's invalid, that's valid. Now if I do need to break this up, there are ways to do that. If I need to split it because of texturing, we can do that. But each object or each element of each object must be composed of self-contained convex objects with no coplanar faces, or coplanar polygons. Now we're going to demonstrate another kind of geometry that's invalid for world geometry. And the easiest way to do that is to use an example like a teapot. This is invalid. You can export this into source, but it has to be a model. This cannot be world geometry. It just can't, because it's concave. And if you don't understand what concave and convex are, you should probably go on Wikipedia and learn about them, because those are a huge difference between models and world geometry. These objects back here, all of these boxes, and the cylinder are all convex. This object is concave. And we'll make another concave object just so you can see. specifically. We'll go to the extended primitives and we'll do an L extension. This object is also concave. Now, there are ways to create objects that appear concave, but they still must be convex. This object is concave because it's one object, and if we break these parts off, there'll be holes in them. So just remember that. So the next thing you have to understand about using Max as your level editor for Source is that you have to tell the system what is your world geometry and what are your models. Unlike Hammer, where everything you design is a world geometry piece, in 3ds Max you can have both world geometry and models all in the same scene. So I can right now set this up to export, but I would have to tell it that this is a model and all of these are world geometry. There are a few methods for doing this. One, to tell the system that something is world geometry, you have to tag it as world geometry. And you can do that by selecting your objects, going to Wallworm Level Design, and then set selection as brush geometry. At that point, when we export the scene, those objects will export as a brush. However, at this point in time, both the teapot and this wallworm.com model here will not export yet because the system doesn't know what they are. If I want to export these as models, I would have to tell the system that these are models. And we do that with the Wallworm model tools, and you create what are called Wallworm model tool helpers. If I click pick model, now the system knows that this piece of geometry is a model because there's this helper in the scene that's storing that information and will export this as a model. These other objects, however, remember, are world geometry because I tagged them as such. If I don't want something to export as world geometry that I had tagged as world geometry, I simply select it, I go to level design, and you hit remove selection from brush geometry, and that object will no longer export as a brush. Another way to set objects to export as brush geometry is to create a layer in your system, and any layer you create with the name of convexity walls will automatically export. And the reason I use this name is because it makes it compatible with scenes created in an older plugin called Convexity, which automatically had such a convention that it would name walls convexity walls. Just keep in mind that you have to remember what it is you're making, whether it will be world geometry or a model, and if it's going to be world geometry, you have to let the system know by either putting it into a proper layer or by tagging it. So when you're making your geometry and you're making your world geometry, stick with the type of geometry that is valid. So if you're coming from a Hammer background, you can always start by using boxes, which are like cubes in Hammer, spheres, and if something like this might not be a great idea for world geometry, but you can use such objects. Also cylinders, but remember again that the height and the height segments must be limited. Other objects such as torus, teapot, a plane, etc. are not valid, and you have to remember that. So it's up to you to understand the differences between the types of geometry, how they're used, and how to tag them. Once you understand that, you'll find that the system is very robust and you'll be able to make your design exactly how you want it. That ends this lesson, and the next lesson we'll talk about using material libraries and materials on your world geometry. This is Sean Olson. You can learn more about Wallworm at wallworm.com. Thank you and have a good day.